Given a vertical cylinder capped by a piston weighing 990 grams contains 100 grams of air at 1 atm and 25 degrees Celsius, calculate the maximum possible final elevation of the piston if 100 joules of work are used to raise the cylinder and its contents vertically. Okay, assume all the work goes into raising the piston. First of all, you can draw a flow chart, but I draw a piston to show all the given variable. And in this problem, given that the cylinder is kept by a piston, so this is a perfect example for closed system because it's kept by a piston and during the process, no mass flow in or flow out of the system. And then write down assumption. What do I assume to achieve the goal? Well, because based on the problem statement, the system is not moving around, there's no velocity term, so we can say that there's no kinetic energy involved. And I also ignore the heat by friction because obviously it's not given any friction factor. We can't really calculate the friction force or the heat caused by the friction. And we can also ignore the internal energy because it's not given any information to calculate that. Although I can probably calculate that, but there's no change and I don't want to make the problem too complicated in this problem statement. So go ahead, ignore that for now. And also ignore the potential energy by the mass of the air inside the piston. Well, the reason that I ignore this part is because the problem is asking for the elevation of the piston, so piston is a focal point. That is the thing that's doing work. And also, the mass of air is the air molecule, that is a gas phase. It's difficult to measure the elevation of the gas phase because they will be everywhere filling the cylinder. So it will make things complicated to calculate the potential energy by the gas. And also, comparing with the mass of the air with the mass of the piston, the potential energy caused by the air is a lot smaller by comparing to the piston potential energy. So I just ignore potential energy caused by the air inside the piston. Then I also want reader know what variable mean in my equation, so I also write down the final elevation is z, initial value elevation is z sub 0. So let them know that the meaning of the variable I use in my energy balance apart from the default variable that we learned in this chapter. Okay, so based on the analysis, we know that this is a perfect closed system, and material balance for a closed system is that input minus output equal to accumulation. And the input of this problem is, well, again, I say ignore the mass of the air inside the piston, so I just simply use input is just the mass of the piston. And, well, there's no output because the piston is not removed. And so it's simply input equal to accumulation, that is 990 grams given by the problem statement. Next, write down energy balance. Well, for a closed system, the energy balance is change in internal energy plus change in kinetic energy plus change in potential energy equal to the sum of heat plus work. And like I said, this is a closed system. There's no flow, so there's no dot on top of the energy term. Then based on the assumption, I can cancel the term that are negligible. So I ignore internal energy, so cancel out this term, no kinetic energy, and there's no heat caused by the friction. And also, we see that heat is the energy flow due to the temperature difference, because the temperature given here is 25 degrees and there's no final temperature term, so we don't know if energy caused by the heat due to the temperature change because there's no information given for that. So we can cancel out the heat because there's no temperature change. Did you get that? Therefore, we cancel the term, then we can get the net energy balance is simply potential energy is equal to the sum of work. although it doesn't talk about what kind of work, but it does say that 100 joule of work are used to rise the cylinder. So this is a sum of work on the Ravel equation. Then simply substitute the equation with the number of variable given. Then we only have one unknown variable. Then you can solve that easily.